So recording now.
Yeah.
So can you guys see this list here?
We can, yeah.
Yep.
Okay, so since Bob Hamilton just joined us, so Bob, have you, I mean, we'd like to set up a redundant server. We need to send this OSSMID to Michelle, I guess, to register.
Okay. I'm at home. I had a dentist appointment, so I just got in.
Okay. So on number 4, we have to have a gateway able to print out a link, a PDF that's linked to, blocks. So yes, when it's in this item, yeah,
that's
right.
okay.
Okay.
Yeah. I need to follow up on this. Okay. Yep.
And also, yes, we're investigating the script to how to select in-spice simulation, between Verilog and sub-circuit. Yes. And also we have a demo in the inbar, but we need a kind of work section of the demo, inbar demo.
Yeah. I have spent quite a bit of time on this, and there's still some issue happening, so I didn't want to just demo what I was able to see now. So they're still working on fixing some stuff. So we kind of switch the order, and as soon as they're ready, then we'll track on the inbar.
Those are the inbar questions. I don't know, have you take a look from our first demo?
I there's a lot about that, but I got the answer I was expecting. Let's put it this way. So it's still up in the air. I still owe you some answer on this. I don't have anything I can share at this point, but
okay.
I know I need to follow this as well.
Today, so we want to go over the back end. I have a specific question on the back end. So yes, I would turn it over to you.
Okay, share my screen. Can you see this now?
Yep.
Okay. So, today we wanted to basically concentrate on backend, which means exit our layout editor tool, and how far we're going to get into, depending how much time I think we blocked an hour, depending on the amount of question and all of that. But my goal was to cover export the layout editor, DRC, the LVS, and the extraction, and even bridge into the back annotation, so whatever is extracted can actually be simulated by the engine, by the simulation engine. So if you recall, when let's start from gateway. When I cover it, I just want to start from the little example, seeing basically the XD10 example, the CDK idle example. So I'm just using the quick start example for this demo. But if you recall, when we covered gateway in July or so, I said like 3 ways you could netlist out of gateway. You can netlist for for simulation. You can netlist for NDL, for netlist driven layout, or LVS. So what I did from here, from this circuit, I said create specific netlist. Then I chose Guardian, and I created the comparator_LVS.net. This is the netlist I'm gonna LVS against when I have my layout completed. So I'll just take that.
Michelle, I'm sorry to interrupt you. You say one of them is LVS or LDS?
Like Victor, layout versus schematic, basically.
Okay. Got it.
Yeah. So as you can see, those here, I basically the VC and the V pulse basically do not have an LVS string because that's just power source are there for generate the stimulus, right? So they have an LVS string or an NDL string. So basically that's what their string is for LVS and NDL. So that's my LVS.
Michelle, I have a quick question. So we start the simulation from gateway, and as far as I can tell, we can start in 3 modes. We can start in piece-wise mode, edge-wise mode, and a spectrum mode. Is that correct?
Yes. In the preference, your simulator, you have different HSpice mode, Smart Spice RF or Smart Spice.
Join the meeting.
If you want to simulate in spectrum mode, basically you need to directly Smart Spice with the switch minus. When you launch Smart Spice, you would just type minus Spectre, and then it is in Spectre compatible mode.
From the preference menu?
Well, if you're at gateway, you're going to generate a spice string or something that will look like a spice string. So what is going to be generated here would need Spectre format, right? So if you have a Spectre netlist that you would need to simulate, then the best thing to do would probably just use that Spectre netlist, but launch directly Smart Spice like this. But if I do, for example,
right,
just add, if I do Spectre here, and then Smart Spice, it's telling that right now it's in Spectre mode compatibility, right?
But you can use P-Spice stimulus.
Yeah.
Yeah. So that's where the confusion, because Spectre is definitely on its own. I mean, if you use cadence, but can you also generate Spectre next from the gateway?
Well, if you wanted to do that, basically the PDK, each symbol would have a descent, for example, here. That transistor, if I click on it and I look at this netlist preview, this is set up for spice syntax, right? So they're meant to spit out the Spectre format, but one would actually say, okay, well, I want to modify this. So you would actually go and edit that symbol, which is in prime, the NE in PrimeLib. So if I go in PrimeLib and I look at the NE device, I do that and say, okay, the spice string, I'm going to modify that whole string so that it's going to be more of a spec format when it spits it out.
Do you have a guideline of how to modify that into a Spectre format in user manual, or?
I think so. I don't know of any, but I will ask if there's something out there that might be available. Because I mean, our guys need to know going from caliber from Spectre to Spice, so they have to have some type of mapping of syntax somewhere somehow, right? So I just don't know where it's sitting, but I'll take that down as a question that you would like to see that if available. Okay, hold on.
Yeah, what I'm asking is that, I mean, sometimes for same circuit, same stimulus, whether you run the PSpice, HSpice, or Spectre, you got different results.
Yes.
So the question is, who do you trust,
Well, I know. It's always a good question. So there is, going to the type of simulator, if you go to Edit Preference out of Gateway, you could pick SmartSpice or HSpice. But if you wanted to, like, say, launch a spec run, you would leave that here to whatever format you want. But when you would generate the netlist, you would not actually generate the simulation from within Gateway. You would need to basically get that input deck here, and then have that to Spice in Spectre mode. And your syntax for all your devices would need to be Spectre syntax, right? Even the stimulus and the include and all of this.
So this way you can directly launch it from Gateway. You have to go out of a Gateway and then run it in SmartSpice mode.
Correct. There's no way to launch directly. Well, hold on. Correction. I guess if you were to come here and want SmartSpice, and then just add the command line -Spectre.
Oh, okay, got it.
Would probably just launch SmartSpice in Spectre mode.
Right. You would have to generate a netlist in Spectre mode, right? Or
correct.
Rather, it can be also SmartSpice net. It's just a Spectre model.
No, in that way, it's going to expect a Spectre netlist.
Okay, that's the way. Okay.
Now, like if you have a SmartSpice netlist and you point at Spectre model input deck of SmartSpice, you will need to go in the input deck itself, or in the control file here. Let me see. Okay, in the control file, before you would do the include of the model, if those were to be Spectre model, you would do, I think it's I'll get the exact syntax, but it's something like syntax equals Spectre, and then for this point on, until it encountered the syntax equals Spice again, it's just going to work in Spectre mode. So you can trigger on and off the Spectre mode through all the same deck, basically.
Okay, so theoretically, for one circuit, I can run 3 different servers in one shot.
You can run SmartSpice, you can run HSpice, and if you point at with your SmartSpice input deck, you could point at Spectre model which should be a match when the foundry provides HSpice or Smart Spice model or whatever, should be a match. But if you expect there might be a different inspector model and some other type of model, you could, yes, use Smart Spice and point to spectrum model.
Okay.
Can I ask this?
Right.
When you say spectre, HSpice, and Smart Spice, so all the same simulator is just the passing of the syntax. You have a parser for 3 different syntax, but they all go to the same simulator, or you have 3 different simulators that work with different syntax?
You have some simulators. The way they code in the time step control and a number of other things is slightly different.
Okay.
Yeah, have access to 3 different simulator tools, then yeah. But if you use Smart Spice in Spectre mode, what it does, it kind of does a conversion or a parsing of the Spectre deck into the equivalent Spice format, and then it runs on that converted Spice version. Does that make sense? So, so what I was saying earlier is those devices here are not something you want to lay out. So for that's the reason why when I do the Creativic netlist, and then I pick NDL or S, which is the guardian. If I pick the NDL netlist and write that, you will see that those actually do not have any string. When you look at other device, the difference between the LVS netlist and the NDL netlist is that the difference, at least, is that in the NDL netlist you actually have coordinates that are where devices are placed in reference to each other. So the original placement of the PL or instances in the layout will be based on that placement. So obviously your final layout is not going to look like your schematic, but the original placement will kind of look similar to kind of give you a feel to find different items, right? So let's say we're happy with this, we simulated it, and we're all good to go. So we're ready to do the layout. So from each way you can launch Expert, or you just use directly the X icon here, right? So if we launch it from here, all right. So in Expert, you can basically just open a GDS file directly. If you just file open, you can just open a GDS file directly. You do not have to specify a text file. If you get GDS and you're not quite sure what technology file it comes from, just open it and look at it. It's going to just name layer like layer 1 D0 for layer 1 data type 0, layer 2, layer 3, and assign color, but at least you'll be able to see the structure of the layout, the hierarchy, and all the data. In our case here, we want to create a project. So I'll just create, a demo. DL demo. And the text file will need to be from PDK we're using. Found this guy here, and I'm just going to create it. Is it in the? Yeah, okay, that's at the right place. Okay, so I'll just create it there. Okay, I'm going to need to activate my PCell library. So on the library, you have access to the PCell. I already mapped it, but you can look at basically the P of it. So when you map it, you basically just browse to the path of the ELD file, that is the PCell library sitting in the PDK. and the logical name is, it just steals the name from here, basically, and just name it. If you want it differently, you can, but it just goes by default with the name it is there. Now, if I do cell open, I have my library to the left, my project, NDL demo, and then my P cell library, which shows with little p, that because those are parameterized cell. The PHA here, it's a standard cell. I think it's a bipolar. So now, there's option in expert. I'm not sure we're going to cover everything, but I'll go through the flow, and as you have questions, stop me. We can look at more stuff more specifically. If you want to bring in the net list that we just generated from the schematic, you do Tool, Netlist-Driven Layout, Net List, and then you just browse to the netlist we created, which is the MDL netlist today at 153. That's the one. Okay, go. So you do this, it brings in, it creates the hierarchy of your project to the left. So operator_sim is my top. There's two sub-block, train and output stage, and it shows, different component in there, their parameter that's going to be passed to the P cell, and the thing that happened. It knows that the device NE here to be mapped to P cell NE located in XDM10 cell. Does it know that? It was already mapped, but if it doesn't come up like this, it's because it's not mapped yet. So you can go and load the map that is located in the PDK under NDL folder, and then it would find it. So once you have that, you can just generate or create your top cell, and doing so, it's going to create all lower level cells in your layout. It places basically my comparator and my output stage. Let me shift that to the left a little bit. Here we go. If I press I can see that there's some P cells that were placed. If I press I and I keep looking deeper and deeper, I can get a transistor. Same thing here. So proceed when I have something along those lines. I want to descend into one of the lower block, and then I have the transistor that I need. More closer to the origin. Now, when you read the netlist,
you said shift it closer to the origin. How do you see the origin?
Oh, okay. So if I move guy here.
Oh, okay. Got it. Thank you.
Yeah. So come on. Okay. By reading in the netlist now, it knows all the connectivity that needs to happen, and you have, and I already have it there, the net basically that are involved in this sub block, right? You have in, you have out, VDD, and VSS. Yeah. So if we're going back here, you have in, out, VDD, VSS for that output stage. I descend into it. In, out, VDD, VSS. That's basically what I see on the layout here. But I see it yet. So how do you bring this window up if it wasn't there? Just by right-clicking next to the word help, you basically have access to the menu of duck window and toolbars. Duck window nets is the one that actually gives you access to those nets. Now, if you use this toolbar here, NDL toolbar, you can turn on what we call flight line. No, not yet. So let me duck back in. There. So let me show the icon a little bigger. I think that's a little small. Toolbar. Okay, let's going to be a little bigger. Maybe that's not how I would use it, but at least you'll be able to see it. So now I have some flight line shown. You can imagine that if there was a lot of net, this would look like spaghetti. So what I usually do, I'll say, okay, just show me the flight line for the pick net. And we'll go and see only in. So it's telling me that for in, I need to connect basically bar of poly from this transistor to this bar of poly from this transistor, right? So if my layout's not going to be super elegant, I'm going to wire it up. And then if I do it, create object contact, I could pick visit poly contact, boom. And actually, yeah, I want a metal one to poly. I'll just slap metal one on top. Oh, it's there. Okay. Now, as you wire a net like this, you want the net to go away and show that it's completed, right? In order to do that, it might set up already, but I'll show you how to set it up if it's not. If you go to node probing, re-extract connectivity, or re-extraction options, line change, I'd like it to prompt me for re-extraction instead of re-extracting automatically every time. To rebuild the derived layer, so it's almost like it's doing a little LVS on the fly. And I'm going to tell it which LVS deck to use. In specific PDK, we have what we call an NDL script. But in bigger PDK, so we use the normal LVS script for it because it's just a demo PDK. But in bigger PDK, you have, not the full LVS script or extraction script, because what you care about is basically routing, not extracting the device or anything like that, right? So it could be a subset of what the full LVS script is, basically. So with that being set up, if I tell it re-extract connectivity, yes, it was telling me that in is wired up, it's finished. VDD is finished because there was just one connection, right? So it's telling me, oh, that's completed. Out, if I go and show out, I could say, okay, I want to wire out. Google, then run. So it is completed, and then I will need to wire VSS with a substrate tie and all of this, right? So you can build up I'm not going to build it all up, but you can build up your hierarchy like this, and then when this level is completed, you basically tell it using, if you that this, this piece of metal one, okay, it doesn't, it does a metal one. Draw a little piece of metal one. You tell it that this piece of metal one is actually the pin in, and it's a pin, true. Save. So when you go one level up, we know where to find that in pin. So the flight line will not go just to the instance, but it's going to go directly to where that port is that you specified. So you build up your hierarchy like this, up and up and up, and it's kind of an LVS on the fly. When you end up with all those check mark done, I don't know why it disappeared suddenly, but when you end up with all those check mark done, then it should be LVS clean according to the incoming netlist. There might still be some LVS issue, but that should catch most of it, right? Because the PL are sized properly, so you're not going to end up with parameter error or anything like that. If it's a standard cell, oh, that's one thing also. Now, in this test case, all good. I'm just using PL and cell that are in the library. But most often, you won't start a layout from scratch. You're going to use a sub-block that you used in a previous chip, this analog converter, blah, 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 that you know you can reuse, so you're going to bring it in, but you don't want to relay out the whole thing. So what you can do is bring the cell in and place those little ports on it for input and output of that block. And in the mapping file, I'll show you. Find the PDK, yep, SCDA tools. Gateway, tech file, and in the mapping file, would basically add to this, because right now it's telling it NE is found in the P-cell library, blah, blah, blah. So it's a mapping of each device and where to find them. You could add to this and say, okay, DC32 will find in my project DAC32AS, whatever, right? So it's going to know to actually find that. And it's going to place the flight line to that block. So it's not going to try to relay out the whole thing. It's just going to use whatever is placed in the project. All right, hold on for a second. Hello. Please leave a message after the tone. All right, about that.
Hi, Michelle. This is Candy calling from 24 Hours.
Hold with me for a second. Okay, I'm back. Sorry about that. All right, so basically you could have sub-block that you reuse directly, and it will place a flight line directly on them and all of that. So, now, we're not going to build the whole thing there. I have that all prepared, so let me kick out of that expression and bring in the one that is kind of prepared. Any questions at this point?
Nope.
Okay. With this guy. So, let's open this one. So as you see, I have this lower level block, cell descent, that I wired up with the VDD and CSS with my subtie. I have this one here, cell descent, that I wired up also with my label and all of this. So at this point, I'm thinking, well, this is all wired up. Go ahead. Okay, somebody has a question. So, let's go over that verification tab, which basically covers DRC, extraction, node probing, and all nice little feature. So for DRC, we have, well, there's two ways you can run DRC from within Expert. We have our own engine, Guardian DRC, and on the Linux version, I don't have it here, but on the Linux version, you can actually, if you have a Calibre license, for example, you could launch a Calibre DRC run from within Expert. It was like ping and format the data, so it passes the GDS to Calibre, DRC run, and then it's the database that you can read back in and inspect your error directly from within Layout Editor tool. So let's look at verification DRC script panel. So in our PD we provide under Expert script DRC, and this is kind of the syntax, right? So you have a mapping, and this will be provided to you, right, from any PDK. So I'm you played with that before. There's some setting option at the top for, checking for antenna. Are you checking for, what metal option you're using? Different PDK have different at the top. That's basically it. You have some preferences as far as the DRC. Tolerance, usually I put it to 0. You don't want to have it like a 10% or a certain nanometer there. The scope, you could do only the selected shape. You could do only a cell own shape. So basically the permits that are placed in, not the instance. You could say, I want to run on a cell-wise, so it's going to open every single cell from where you're at that it sees and run the DRC deck on it. Or you could say run full hierarchy. You have some option as far as like the type of log you want to run. Append brief, are you adding on, or you creating a brief, or you're just creating a new log every single time. Grip option, you want a progress bar, stuff like that. And then you have parallel mode. If you have a long DRC run or a lot of data, a big chip, I would take advantage of this. Small run, I would not turn it on because the overhead will actually kill the performance. The overhead having different thread you're not going to gain much, basically. Now, the DRC is flat, but you actually have the option of representing your data in a hierarchical way. So if I turn this on, I run this DRC script. Okay. Now, this toolbar here is basically DRC inspection. You want to load error. This, when I load the error, it's okay. I run on this cell. It was a hierarchical run. It took that much time, 18 error. So if I click that and I say I want to see tree view, basically, this. So for this error, it's basically telling me the top is clean, but it's some error in it. That's why it's yellow. Output stage DRC, output stage cell has 4 error of this type, which is a width of T-well. And that's about it. Compare is clean. So kind of the way it would show if you choose the hierarchical way of representing your data, right? Whereas if you go and just turn this, just get it's still flat, same time as far as like basically the raw itself. And if you load it, preview, there's no tree view. It's just like the same thing. So look at, for example, the outdistance metal 1. You load that. You can detect the error using this toolbar. This brings you to the first error. You can a little bit and increase visibility by pressing I or U. And if I click on metal 1, I can see this active layer in stipple mode. It's a setting basically in the editor where you could tell it that you want your active layer filling to be in stipple mode instead of wireframe or default. I like that personally. So you see there's a notch here basically that gets created. Now if the next one, it zooms way in, to the next one it zooms way in. Now if you want to stop the zoom way in effect, basically you could start to a level that you like and just say, okay, use about that zoom level, and when you jump to one to the other, it kind of keeps that same zoom level. So you can see your error, and you're not totally on it. So if I load the error, I can go load another one. What's one? Width less than 10 for the P-well. Okay, so let's go see what it is. If like first there. So it goes dug back in. There we go. Alrighty. So I'll just bring that here. Yeah. Okay. So if I turn on my IP well, oh, depot mode is not active. Here we go. This PUL block here is actually too small. It says, basically at a 9.7 width here when it should be bigger. So this seems to be into my low-level cells. If I start in, I can go here, basically just enlarge my PUL there. Screw that, and just stretch it out. That should do it. Leave, go back to the top, and then you could just rerun, reapply the last script, right? Okay, unload, reload. Now this went away, right? You can see you have like basically the W1, WP is gone. So then I have to go and do the same thing with all my spacing, metal, and all of that, right? I do have one that is actually clear. I go to this guy. I believe it's clean. Let's assume it's clean. Let's look at the extraction and LVS portion of the verification. It goes into two steps. We first generate the net list, which is the extraction step. Then we LVS. You call it directly from the GUI, or you could run it in batch mode. But there's extraction setup, and every PDK will come with a template. It could be tweaked to whatever you're after. So if we go to verification, extraction, setup, what do you have? So first page is basically what project you're going to run on, the cell you're trying to extract, do you want on the layout or not. The use of this here is, okay, with net list, you have the option of setting some block. For example, my comparator sim is set as a H cell. My output stage is set as a H cell, which means it's going to extract a net list for that cell only, right? And then, so it's create a net list of the layout that will have some hierarchy to it, and you're going to have some sub-circuit call at the top to those lower level blocks. So it really kind of has a hierarchical net list. Once you have that all set up and you like it, if you run a flat run at one point, because you're not sure that the LVS extracted list hierarchical doesn't match, and you're like, well, let me see if I run that flat. Maybe I'm missing a tab in a cell and it's one level higher, so if I flatten everything, maybe it's going to start to see it, so let me try that. Well, you want to go and break all this setting that you set, very precisely for each cell. So then that's when you would come and say, this will override whatever setting you did, and just flatten layout for the extraction. What rebuild derived layer needs to be on, because that's basically telling it, go on the LVS script and generate all this crash or pseudo layer that will be used to recognize the device and any connectivity and all of this. Write device label into layout. I have that on because it's just gonna write on the gate or the base of a transistor or the body of a resistor the spice line equivalent that is put in the netlist. So sometimes it's kind of nice to see, oh, this one is XM22. Okay. So I kind of like to have that on the little one as extracted. On the name, this is just like the look and feel of your layout. We write some default, if not like it, and the default node instance, for example, default instance prefix, you would like it to be you could do that, right? But rather just set to I or capital I. And the default prefix right now we have like pound. So if a net is not labeled, it's going to be like pound 22 pound. So you could say net, and then it's just going to, or N for net, you know. So right now it's set to pound, and you can do all of this. You add the location of the generated node name. You could have, it makes for a busy net list, but sometimes it could be useful. You could see some global node name here, and that's about it as far as this is concerned. On C, what do you do with dangle node? For example, are you going to report dangle node? Are you netlisting the subcircuit dangle pin? So use I'll netlist them. Open node, rename open. This is pretty important. For example, if you're working at a lower level cell, we have 4 line of VD, but they're not jump together yet. They just go across your script, but they label VDD, and it'll be all jump together 1 or 2 level up. When you track that, you may want to turn off the rename open so that it all labels them VDD base labeled and just assume they're connected together. But when you're at the top of your layout, that would be dangerous to leave that unchecked, because you may have like 2 sections of your circuit that are labeled VDD, and just based on the label, it would say, oh, that's VDD. Say rename open here, it would basically extract the first VDD as VDD and the second one as VDD_1, telling you they have the same label, but they're actually not physically connected, so you want to look into this. So it's just what this is used for. If you shorten net, what do you do?
On that.
Go ahead.
On this rename or and stuff like that, is there a different way to do it from a cell basis to the chip basis?
Well, usually my view on this is usually at the top it would always have it on. You always have it on, because when you're at the top level, you know, unless you have like 4 pad of VDD, right? Then yeah, they're going to be labeled VDD, but they may feed different sections of the circuit. Even then, what I would do when I run the extraction, I would say rename open, and I might jump my 4 pad together with a little bitty wire, and this VDD, 1 net. And there's a section of VDD at the top that is a section of circuit that just label VDD, but is actually not really connected to the network, it would tell me. So at top, I usually use that always on. But I'm low level, yeah, everything is wired, and I don't have a multiple bus named the same that will be jumped to get 1 level up. Yeah, you can have it on. Sometime, you know, during the extended cell kind of layout, you may have like your ground VDD, and they're not all tied together. So you may want to turn this off. So that's just the way I make the distinction. Does that kind of clarify your question, or? Okay, maybe I didn't understand your question properly. Try me again, then.
Well, I think you probably answered my question. I'm coming from a different perspective, so that's why I'm confused. As a, for instance, what I'm thinking is some BS tools will allow you to attach text. Like text on layer 20, for instance, I'm going to attach 20:1 or metal 2, whatever. And then in a case, so I could do that at the chip level. I could also do, say, 19 I could use at the cell level, so I never wound up getting connection when I didn't anticipate it. So I guess the perspective I was asking the question. distinction from.
I see. There is no distinction of, for example, a Metal 1 text that would be for cell or top. If Metal 1 text is allowed to attach text label to a piece of metal, it will do it whether it's at the top or lower level. We have some way of telling it, I want you to accept text only one level down or only at the top, so it doesn't start looking at label that might be lower in the hierarchy and then get confused. But there's not that distinction that you're actually asking about. We do have labels that we use Metal 1 text, which will just attach a text. And we have often also Metal 1 port or Metal 1 pin that will attach a text and generate a port out of that piece of metal. So in the example of my output stage earlier, is to netlist out that output stage. Maybe I want that input line right there where I put that little text earlier or that piece of metal earlier. Basically, right here, I would want this block to have it in right there, and this, when you force a port, also this will not get renamed when you extract parasitic. Basically, if you extract parasitic of your top cell and you just put port, your name, which was like input A, may get renamed, and input A might be gone. But when you force it to be a port, then this will, at that location, be the port. Like this is where the bonding pad would sit, basically, or the bonding wire would sit, basically, if you look at it this way. And then your resistive network or capacitive network for parasitic would start from there. So you can ensure that you still have that name that you're probing or you're passing stimulus to. So that's the two distinctions that we have when it comes to labeling. But I like the idea, actually, of having different function, whether you're at the top or lower level. So I run that by the team. Maybe it wouldn't be.
Okay. Well, since I'm behind on the curve on this, maybe the difference between attaching text and having a port, maybe you do have the distinction. And I'm just not quite following the whole scenario here.
It's same thing. So I can see both having some usage. So I'll check with the team.
Okay.
Okay. So all right. So that was rename open. Here, when you have some shorted net, right now it's set to pick node among multiple label. It is kind of dangerous because it didn't tell you in the log, but I usually say generate unique name. So if you inspect your net and you have like multi-label, you're like, well, okay, I have some short because I know how to name that net, right? And then also improperly connected transistor. What do you do with BGTDR base and shorted connector? You say I don't want to report it or I want to report it. It's just going to give you an error. Just spit it in the log. You have your soft check error also that are provided for the PDK. If the substrate receives nodal information from two different nodes, it's going to tell you, well, right now you have like part of the circuit that is connected to the substrate, and then one down, one is like A, so something's wrong. So it's going to flag it. Explosion, we kind of covered that a little bit earlier, where you could go and specify each cell. Explode will basically just take that cell and explode it up in the level above. So it's not an instance anymore for the level above, right? Smash, flat, or flatten will destroy all hierarchy. Well, it doesn't change the layout, right? It just, in the action routine, it looks at it like if it was flat. So, so you have like different thing there. Net listing. There's like how you're going to name your net list, the different attributes that you want to have in your net list, MOSFET, MW, source drain parameter without the W, resistor and MW. What do you want to spit out, basically, right? Parasitic resistor, that's the name of the net list that you're going to generate when you run the parasitic R. Right now I'm spitting out the location and the layer that it's caused by. Per capacitor, you have a coupling threshold that you can set. If you set that enough, net will be coupled to any other net. They're all going to be referenced to ground, basically. It doesn't destroy any or ignore any capacitance. It's just like basically lump everything. And then your RC net list, and tap to where the DSPF and the SPEF file would be located. Then what do you want to generate? Okay, I want to generate just come to parasitic. I want to generate a SPEF, SPICE, the DSPF, the SPEF. When you want to simulate the back annotated netlist, you'll want to comment out the dot model statement because that's not going to be really understood by the SPICE engine, so you want to comment that out. Technology, where to find the LVS script and the parasitic C and parasitic R coefficient file, the unit that they're using. Parasitic extraction, here that's going to be, this section at least will be provided to you in a PDK. It's basically a mapping that is occurring between the parasitic C file and how they're named in the tech file. They're the same, but sometimes they're slightly different, so there's a little mapping that takes place. But most of the time, they're the exact same name. If we can, we'll make them the same. Now, at the bottom here, you can, for parasitic resistance, there's a serial merge threshold. So basically, you have some small resistance. You could say everything under 2 ohm to any neighbor resistor if you can. I want to minimize the netlist size. It doesn't change the structure of your netlist. It's just going to try to merge if at all possible. Leave it to 0, then it doesn't merge anything. It just like gives you everything. Do you want it in your power node or not? If you're thinking my VDD and my ground are rough, I don't want to worry about this note on this, then you can ignore it. RC reduction. If you want to reduce your RC netlist, you can use one of the 2 ways there. And finally, specify the number of threads that you have on your machine. For big run, yeah, turn it on. For small run, maybe leave it off. CRC. If this is mostly if you wanted to reduce if you reduce a kind of a third-party netlist, somebody gives you a DSPF netlist and you want to reduce it, you could go and set some reduction criteria here and use that to reduce it. If you use Hypex in your context, you would. This will do basically the same job, so you would not actually need the CRC. The tab here, it's basically to allow back annotation. So when you're happy with your LVS run, then okay, It's LVS clean. My layout doesn't quite have the same net name as my schematic, so I can't use that net list right away and simulate it. So I'm just going to basically run a back annotation. And what it does then, it actually look at the LVS mapping file that says what match with what, and go and steal the name, basically. You can look at it this way. It goes and steal the name from the schematic and populate the layout net list with the schematic net name equivalent. Then you would find your net that you're trying to probe and pass stimulus to. So you could simulate that net list. So that kind of goes over the setting. Again, this will be provided as a template. Usually I have a setting for pretty much all my cells because sometimes they'll be set a little different. So you can save your setting, say output block A. You could say output block A extraction setting, save, and you can call it back at a later time and look how it was set up when you extracted it. So that's kind of it. Now that we went over all of this, let's run the extraction. So this is your extraction toolbar. You have access to it for this verification DR extraction setup and all of that. Or you could just say net and see if it runs. Okay, so it's Guardian Net run completed with the error inspect summary. So let's look at the type of information that could be caught right at that level without even like running LVS. So if you look at the summary, slide that. Okay, so you have a short one detected. Okay, so there's a short. There's short, and there's some number and some message. So down. It's have a short between VDD and out, and it me the coordinate of that. So I could correct it right there. As I have a port short, so it cut it twice basically between VDD and out. It says I have a multi-labeling on the VDD and out, multi-label, and that's about it. Port or text, So let me turn off the multi-labeling because right now, if I inspect, let me see, if I inspect this, if multi-label, yes I do, and I don't want that right now. It's good to have it. I just want to show you it's going to kind of throw a monkey wrench in it. So let me turn this off. So let's rerun it. It's still got that there's a port short. Well, the summary. It still flags it, right? But it doesn't see multi-label when I look at the net list, right? You could go and look at the nets by HyPEX net list, or this little icon here brings up the net list. So like I said, I have a hierarchical net list where I have two instances. Now my top circuit is commented out because in setting here, I comment top subcircuit. So if I cut it out, apply, rerun. Open this. Now it's not set up, right? So I have my two instances, my sub instance, and all of that. So I'm thinking LVS clean. So let's say I really look at the report, and I want to compare that at LVS. So this is my extracted net list. So from here, I can say verification, launch LVS. So it's the LVS GUI. What are we doing on time? More like 2:40. Are we still good, or should we there and keep on the day? I don't know. It's still have time. It's really on side.
I'm fine.
We're good? All right. Let's keep going. So, you can say project setting, where you would get to specify your two-in power. And LVS, so I would go under Gateway, the example folder, Quick Start, the LVS netlist that I generated earlier, right? And the net I just generated out of Expert, example Quick Start, the one just generated is this guy here, comparator sim LVS hierarchical. Yes. There's tons of settings at the bottom here. You provide it in a correspondence file where you're basically helping the tool finding correspondence. You could tell it what the top circuit is on both netlists. There would be in a case, for example, have a large netlist, like the full netlist, but you don't want to compare the top. You want to compare, like 3 levels down. So you could tell it DAC 32 is the top block that I want to compare in both netlists. So it would start from that and going down, right? At the bottom, you have some matching options. These two, basically, this is kind of the early LVS algorithm that we had in Gun LVS. The most recent version. I usually use one because I have better luck, but time to time, this one may give you hints that are more useful than this guy here. So I'll vary from one to another, depending on what I'm chasing, and if the hints that the tool is telling me to debug my LVS issue are not clear, I'm like, well, let me try the other one and see if it helps any. I tell it match same name net, detect label mismatch, match same name subcircuit, all kind of option. You could set up unmatched known limit. If that's your first run, it's a really big circuit, you could maybe use that up so you don't run forever. And then you start addressing. But most of the time, I'll have that on. Give it a shot. I'm telling the tool, just take a stab at it and see if you're able to do it. Then I'll consider helping it by initial correspondence or anything like that. Is if you run a hierarchical if you run hierarchical mode, you could say, okay, first, for example, first subcircuit that you find that are non-equivalent, stop right there. No point of going any further. I have one that is non-equivalent. Let me address that. So that would, facilitate the work a little bit. Syntax, duplicate subcircuit. Okay, here's when I see stuff like that. Usually I'll have it to generate error. It's rare that you're going to have that in your layout netlist. But when you work on the schematic side, sometimes you'll include some libraries, so that you point at some CDL netlist to define some logic cell or whatever. And you may end up where the library will have 2 different definitions of the same block. I know that in the past. So if you say replace previous subcircuit, it's just going to replace, you'll never know about it, and then you're not even sure which one you're using. You're the second one, well, what if the second one is good? Generate the error is the way I go, right? This is just basically remove any character after a certain pound or sign or anything like this. So rarely use that, honestly. Collapsible net, when you're going to run, yes, the tool will try to merge things parallel in series to find equivalence. You have some net that you don't want the tool to collapse for some reason because you're going to probe that net somehow. So you could come say here, I don't want you to collapse, or you could say collapse all net or only numerical net and net with symbol sequence of pound something, right? You have a little more detail or flexibility on this page here, where you could specify for each. Again, that's all thing that you could put in to help the tool finding equivalence. Okay, I'll have that off. I'll just let it take it and just see if I can get it LVS. If not, I'm going to tell it, okay, and the power net and my net list one are such and such, the ground net are such and such, the collapsible net and collapsible net or instance in both net lists, I can specify all of that. Under report, you could say, you could get a path that you want those report files to be saved. Usually, I will have all the possible report on because I know which one's going to be useful to me at the beginning. So I'll have that all on, at least for the first few run. Now, the model tab here, she all set up for you in a PDK provided from us. Because you know that for such device, you need to compare the LNW or the R value, or we know what criteria needs to be compared for each device, so we can set it up properly. What you have flexibility on is like, okay, for MOS, I don't want to allow swapping source and drain because I know, for example, that's not symmetric, so I don't want to allow it. So it's important I lay it correctly. I don't want to filter dangling device or not, right? So you have all kind of options you can play with. For BGT, do you do parallel merge, serial merge? You could say at the beginning, okay, I don't want to read so much about the parameter. I just want to see if I'm LVS clean as far as matching the model. Come and worry about how tight my criteria. Do I need to be like 2% strict on how close I match the tolerance for the length and the width and all of that? So you need to play with all of that. So let's launch this. We have our two net lists. Okay, and once you have it all set up for what you're comparing, again, I'll do the same thing. The same way I have my extraction set up for each block, I'll have my LVS set up for each block. So I can always recall what was set up extraction, what was set up to prove that it was LVS clean. I could always go back to that. Right. So let's just run and see what happens. Okay, so it was pretty quick. It's a small circuit. So I got all kind of report, but this first one here is the most useful one. But basically it's telling me it's not equivalent, and it also tells me I have parameter error that are detected. Now the way to read this, here you have your device type, the device model, and EPE. Before pre-processing and after pre-processing for both netlists. So for netlist 1, which is my schematic, 10 NE and have 4 PE prior to any reduction taking place. After reduction, parallel merge or whatever, serial merge, I have 5 and 4. In the layout netlist, I start with 10 and 4. Makes sense because I generated the layout directly from my schematic netlist, so I would not end up with more devices. And then I end up with 5 and 3. So something is happening because it's telling me I basically have one unmatched device on the schematic side. I have 5 match on the NE. I have 3 match on the PE. And I have a parameter error taking place on the NE side. Now, it doesn't be happening because I did have to go and change the parameter for all the P cell to make that happen. But if you lay out something manually, or you go and change parameter manually on the layout side, this could happen. So I just changed it so we could actually see how it comes up when it does. So when it's something like that, I'll go and look at my unmatched report, right? So it's the number of unmatched net 3 and 1 for net 1, number of unmatched net 2 and 0 instance for net list 2, which is the route. Now, the way to read this here, the step, the list is here above, right? Basically, what that tells you, to the left you have your schematic netlist, to the right you have your layout netlist. It's telling you on the net VDD and the schematic you have 8 connections. On that VDD on the layout you have 9. Wrong there. The number of unmatched connection between netlist 1 and netlist 2, there's 2 connections on the schematic that cannot find an equivalence on the layout. And there's 3 connections on the layout that cannot find, there's there's 2 and 0, and it finds match for 6 of them. So there's the guess that VDD should be matching VDD. There's 6 confirmation out of 8. And on this layout side, there's basically match connection contradicting this guess. On the layout side, there's 3 connections that contradict that VDD should be matching VDD. So we have to investigate that here. It also says that VDD should match with net 5. So something happening there. So investigate that VDD thing. So if you double click on it, you can do list file highlighting, and then highlights that net in both net lists. So this will allow you to kind of see, okay, you know, what's happening. But the most useful one is actually click there and you do the LVS navigator. You click this, and then you lay out. Boom, the whole thing is highlighted right now. So that's the end substrate. So right now, VDD, I mean, it's, you know, it lighted up the whole circuit. So that's kind of worst case. But the reason why I want to show that is that right now I know this is VDD, and it looks like this line here, which should be an internal node, is also tied as VDD. Well, it's pretty obvious what's happening here, but not obvious. So sometimes it's going to be hard to trace what's really happening. When you have that highlighted, you could say, okay, all selectable, yep, all visible. See, okay. You could say I have to use what I call short locator, right? So short locator, I'm going to go and click on a known VDD here, and click on my known node, BVDD, and I'm asking the tool, tell the shortest path between those 2 clicks. So obviously that line will go through that short, and it helps you finding this kind of short, right? So now if I turn off that whole highlight, I can see that my first click was I don't know why it went like this and then like this, but I can see that it goes here, basically jump to my other, which should be out, right? So I can quickly identify that basically I meant to tie this side of the transistor as VDD, and I connected the side, basically, right? So that's how Shortcator is pretty useful. It basically just shows, it creates a layer, short path, match layer, as you can see, it's short path -1, -1, the little F says scratch layer. So if you want to remove it, you just tool scratch layer, clean scratch layer, whole project, boom, it goes away. I do all visible, then I have my whole layout back up, right? So let's try to, try to fix that now. So under my level block, cell this in. It's gonna set that to the proper side here. That should take care of it. Back up. Let me see, so tied here. Yep, okay. Alright, so that's one direction. Let's run the extraction. Okay, still have my net list. Now if I look at my log, I do have the port short anymore. I do have some type of message where I have an unattached ground. So look at that. 44 minus 47. So okay, 44 tab minus 47. Boom. Up there. So it looks, yeah, it's sitting up in the air. So let me just slide that on. Alrighty. Okay. Oops. So if I look at the log now, I have 0 all across. So it didn't catch any error, at least at that level, right? So that's important to kind of, the soft checked error will also be spit out in this log here, right? Soft check. So that's important to catch them at that level. So, okay. So let's go back to, let's close that. Now, the LES tool, I can close all report that I had previously on by just using this icon, close. My name is the same, so I'll just press rerun. It says netlists are topologically equivalent, right? I have like 1044 after reduction, 5544, match, everything match, except I have parameter error right here. If I go to the parameter error, it says this one is 1.25, this one is 2.15. It looks like I just inverted the number when I typed it in. So then I could use the LVS navigator. It's going to be directly into, should bring me, it didn't. Interesting, did earlier. That's the beauty of demo. Okay, try that again. Parameter, navigator. Okay. Well, I know that. If I look at what is it? It's basically in computer train. Which one is it? Parameter error. In X1, XM6, net validating, X6 in compare train. Okay. So if I send into this guy, cell descend, search for XM6. No, it doesn't find it. But I believe it's this guy here. I7. Why does it flag that? X6 and 6. It doesn't make sense. XM7. Okay, let me check something real quick here. Okay, not it. Let me rerun. 4. Did I hear? Rerun. Okay, open netlist. Yeah. one that is 2.1 is XM6. That's it. Okay. So I look for X1. Okay, something's not right. I'm gonna have to figure it out.
On X1 over on the right side. X1 label over on the right of that cell, but I don't see it anymore.
Top one here? Yeah, it's X1 here.
X1, yeah.
It's X1, so cell descend, then it flags this one.
Oh, the XM6.
Oh, hold on.
If you zoom out a little bit, it showed XM6.
Okay, yeah. That's it. That's how it's labeling it. Sorry, my bad. That's it. So, but it should. I did that exact demo. It basically jump, and I like this gate directly, like so. This is the one that is actually kind of too large, right? And then if I click outside, you can see the usefulness of basically print the label. You can see it's 2.1 right here, right? So I could go and change. Let me just remove this slash there so I don't click on something I don't want to. I'm just like that cell and current say 1.2. Boom. Save. Should never happen because the piece would be sized properly, but I just wanted to show what it would look like if you had some parameter error in the LVS netlist, in the LVS run. So if I save that.
I wonder it didn't highlight it because it's a input node that's not connected to something else. Add on lots of LVS tools.
Maybe to chase it down, but I'm basically doing the exact same routine that I did earlier when it worked. So I'm like, why isn't that working? Yeah, I'll.
I have a LBS question. Usually extract with the expert, and then I use the Tanner LBS tool. So I usually lay out on the Tanner and extract with the caliber, Tanner caliber, and it pass LBS. And then I export this to Silvaco expert tool, and then re-extract it, and then they both pass LBS. So it means that the extraction was correct. After that, I extract the parasitic R. I provide this to the David. So we don't know this parasitic R netlist correct or not. So I sorted all the parasitic register while LBS. Isn't that supposed to be LBS if I short all parasitic register?
In the LBS setting.
Yeah. The Tanner has the option. I can short out the parasitic register. So I shorted all parasitic register, but sometimes it didn't pass LBS. So doing wondering that parasitic the net is correct or not.
It should. I mean, that may point out to a broken network of parasitic R somehow. If it doesn't, I'd be interested to look at that test case if you have something you could feed to me, because if you just do parasitic R and then you kind of set those to 0 or ignore them or whatever in the constant, it should.
Usually, I don't have the file. The Tanner LBS tool has the option to out the resistance under certain number. It can short out both the schematic and the net list. LBS.
Okay. Well, you used to have the original schematic netlist, whether it's from Gateway or other tool, and the one that was generated by Hypex R, right?
So the only test one is we have several projects, 59. When I extract parasitic R and then sorted out all the parasitic register, it passed the LBS. The other projects like 3093 or 1280, any other project, when I shorted the parasitic R, it didn't pass LBS.
On the same PDK? Or their PDK?
That's a different PDK, but the same PDK, one project passed, another project didn't pass. Like TO6, one project passed, another project didn't pass.
Well, if you can provide that to us, like any test or any data, I would certainly be interested in looking into this, because that is in both cases. So I don't know why at this point.
Yeah, I can provide you the GDS, but like extraction file, I had the parasitic R. So I run LBS with a Tanner tool to automatically short it out the parasitic register. So I don't have any certain to.
If I have the GDS kind of the parasitic R setup that you have when you ran it, that, and then the schematic netlist, that should be enough to investigate. Yep.
Okay. Then I send test case.
Okay.
All right.
So back to that XM6 that should have highlighted, and I'm going to have to chase why it doesn't. That's basically, I had correct size on it. So now, if I go back to, I reran the extraction, so let me rerun the LVS. Okay, so they're equivalent. And now you have kind of a match report that says for every net on the schematic, what is matched to in the layout, and all of that, right? So if there's any merging or anything like this that took place, the merge report, MR, for example, here, you have like XM5 that has like different, transistors in parallel, same thing on the layout side, so you can what reduction takes place. Now, this match file here will be important when you do the back annotation. So when I mentioned earlier that it came in, it ran the extraction on the layout and basically came and stole the equivalent in the schematic. Right, see, I pretty much named them the same, but on the layout it could have been something totally so different, right? So it would use that match file here to go and, this in the layout, I need to replace it by this because that's how it's called in the schematic. To do that, you actually need to save that setting that you used to prove there was LVS clean. So you save that. Okay, I'm just going to save it like this guy here, LVS clean. Good. And I can now close LVS. I would go back to my extraction. When you want to run back annotation, all after most of the time you'll be after your parasitic, you'll need to run a normal netlist extraction because that's where the back annotation takes place. That's where you compare the LVS, so that's what you're going to need to rerun. And you will come here and turn on back annotation. Well, it was on, so that's why I had the exact same net name. But you need to turn on back annotation. Point to the schematic file that you compare, and point to the LVS netlist that you used to prove that it was LVS clean. And you just run netlist extraction, normal netlist extraction. It comes, there's no error. So if you look at your netlist, that's the net name that you have in your schematic. Those guys here, that you would basically probe or pass stimulus to. You're ready to run parasitic R or parasitic C or RC. If we just run the R by itself, to netlist, now you have your different hierarchy here. You have some resistor, 128 resistors are located at the top, right? Direct comparator sim, and see their value, right? And you have some that are located in comparator train. You have 60 of them. You see their view. You can double click here, and it's going to find it on the net list here to the left. And like I said earlier, because setting during the extraction setup, it's due to mill 1, and the terminal is between this coordinate and this coordinate. So it will be due to ND contact with the location. So this line here could be off. It's just an option. When I bug mode or whatever, I'll want to have that on so I could trace what's kind of going on. But sometimes it kind of makes for a longer net list, so sometimes I'll turn it off. But there's just an option, right? And then you can run by itself. So you'll end up with this that has a cap, 10 cap at the top. And do we have any? Yeah, we have a few cis capacitor there, right? So right now I have net-to-net capacitance. You know, they're not all to ground. If my setting, like I mentioned earlier, I go and set, like, I don't know, 100 picofarad as a threshold net-to-net capacitance and set that up, rerun. Most of them will be just to ground, right? Them will be just to ground because I do not have, well, I have a threshold, so everything will be referenced to ground. So we can turn it back off. Okay. If I run RC, get, you know, RNC at the level, the whole net list. So, you know, you have your force ejection, your subnet, and all of this. When you do so, you'll notice that output stage, now the line in is really broken into 2 in, and may be broken into 2 out. Sometimes like a lower level cell will be connected from left and right, so your subcircuit may not have its original port count, basically. So some have customer that says, well, I want to set a lower level block, but the port doesn't change anymore. What to get around that would be to actually go at that level and extract that level. Then you would have all the data from this level and down with the proper port. They're not going to be split because nothing is actually passed to the top. So, and because we turned on, let me open, because we turned on DSPF and SPF, we're going to also have the format saved here. Yeah, okay, so if we look at the DSPF, for example, yeah, complains about undefined subcircuit, that's fine. So you have for the ground net, your port where it's at, the instants are tied to it, the capacitor and resistors are, involved. For the V-bias net, what's involved and all of that, and you also have the SPEF, which is similar. Well, different format, but kind of same information. Yes.
I gotta go in a few minutes, so I will send you the action item list and
yes.
sketch training.
Yeah. Okay. I was pretty much done here anyway. The only thing left is actually you could use that netlist and do a dot include on your input deck on the schematic side of that netlist, and if the subcircuit is there, it's going to simulate that instead of the schematic, right? So that's to close the loop on what I wanted to cover today. I'm saying you can go, but if there's any question, just go ahead and I'll address them.
I got one quick question just to kind of. Can you click on any top level net and have it hide the whole connection string?
Yes. If I'm actually at the top right now, so if you need to switch into what we call connect mode, because if you're into data mode here, you click on, for example, if you click on metal 1 and I say non-selectable, you click it, it says there's no database connection to metal 1 because metal 1 by itself, that layer is not involving connectivity in that tech file. So if you switch to connect mode, all the layers are actually involving connectivity. So the layer is actually 1SL. You don't need to select it because if you go click on it, the CD, it highlights the whole thing, right? But it come here, it highlights the whole net, and like I'm at the top, right? So if I come and click on this guy, it highlights the whole net. Now, the nice thing too is that if you have like mini net, if you hold the shift button and click, it starts lighting of different color. So if you're trying to trace, 2 or 3 paths that should be of similar length or should be kind of routing to parallel, and you're like, why isn't it? So you could add different one like this, and you just add to that selection. It's like boom, boom, it just keeps lighting on and on, right? So, and if you want that selection to go away, the quickest is to click in an empty space. So just like click on stuff and it highlights.
Cool.
You have also when you have the, let me see here, when you have the DSPF generated, it also gives you the capacitance for that net. And you can, let me see if I can, I believe you can right click, hold on, you can control and control. And okay, so, and then you can also, the resistance between 2 clicks. If I hold the shift button here, and not the shift button, but the control button here, and click, it plays an X, and I right click at the, I left click at the other end. Between those 2 clicks, it's telling me based on the, again on the DSPF file, it says, okay, between those 2 locations, I have 6.77 ohm. Now, it may not be exactly at the location because it kind of fragments, the parasitic resistor with certain, but it's a gram the closest location and give you an estimate of the capacitance and the resistance. But just selecting a net, you'll get the capacitance by default, right? There's total capacitance on that net based on the SPF. So you can highlight.
Very good.
And now I don't have that anymore. I should have showed you that earlier when we had the gateway and I generated the link. But there's no probing happening between gateway and the load, where you can click on an instance on gateway, it highlights it in the expert. It's in the version I have installed. It's really stable. They fixed it for the upcoming baseline release because it was broken. So I'm afraid if I show it, it's going to just blow in my face. But I know it's fixed in the next version. So you do NDL process. If you go that route, you highlight it from one side to the other and kind of trace things. So
no, but you have to do it proxy through the net name.
Yeah.
Highlight by net, right? Yeah.
Yeah. You can basically, VDD. Not VDD. I think it's capital VDD. Oops.
Yep.
Or whatever that net was, ground, right? So you can hide by net. Yep. Instead of clicking. So. Anything else?
Thank you.
No. Thank you.
Okay,
Yep.
so we'll just wrap this up,
Thank you.
and I'll be in touch with Dave and you. And I'll wait for your case so I can look at the parasitic R.
Okay.
Okay, much guys.
All right.
Thank
All
you.
right. Bye. Thank you.
Adios.
Bye.
Bob.
Has left the meeting.
Bye.
Has left the meeting. Left the meeting. A participant has left the meeting. A participant has left the meeting. A participant has left the meeting. The meeting.